Welcome to another video about inequalities. In this video, I'm gonna solve exam level inequality questions which you might see in an GCSE exam. There are 4 different leveled questions and 4 types of questions for each level. It will be better if you just pause the video, try to solve on your own, and then check the answer. Now let's get into video directly, and I'm gonna start with question A1. So basically, solving inequalities and equations are quite similar. In equations, whatever you do on one side, you need to do the same thing for the other side too, which we call it balancing method. And we're gonna solve many questions by again using balancing method. In the first one, x plus y is greater than 11, and I'm looking for single x. X, inequality sign, and a value. That's why I need to get rid of everything right next to x. Here I need to subtract 5 from both sides. And these 5's cancel each out. Then x is greater than 11 minus 5. 6 is the final answer. B1, solve 2x plus 5 over 3 greater than 7. As I told you, we are looking for single x on one side of the inequality and on the other side a value. That's why I need to get rid of everything right next to x. First, I need to get rid of this divided by 3. To get rid of it, I need to do the opposite operation, which is multiplication. So if I multiply both sides by 3, because whatever I do on one side, I need to do the same thing to the other side. These 3 just simplified, and we will have 2x plus 5 greater than 7 times 3, 21. And don't forget that if you multiply or divide both sides by a negative number, then you need to change the sign also. This is valid just for inequalities. Then I continue with subtracting 5 from both sides, and equals 2x greater than 21 minus 5, which is 16. Then let me make it thinner. Then I'm going to copy the question right here. 2x greater than 16, and we need to divide both sides by 2, and x is greater than 8. C1, list the integer values for x if x is greater than or equal to -3 and less than 4. So all I need to do now is list the x values. X can be -3, -2, -1, 0, 1, 2, and 3. It cannot be 4 because it is less than 4 only. D1, I'm going to add 7 on both sides. Then we will have x squared is less than 72 plus 7 is 49. If we have squares, then we say we need to take the square root of both sides. Then you will get x is less than 7 and x is greater than -7. So if you put them together, x is going to be, let me make it thinner, not thicker. X is between 7 and -7. If that sign was less than or equal to, then I was going to use the same sign. Whatever that sign is, I have to use the same sign in the question. A2, again, it is really similar to A1. I'm gonna subtract 11 from both sides, and we will, there's positive 11 and negative 11, they eliminate each other, so just 4x is less than or equal to 29 minus 11, that makes 18. And we need to divide both sides by 4 so that I can have just one single x. X is less than or equal to 18 divided by 4 is 4.5. B2, we have x values on the left side and on the right side at the same time. Don't forget the purpose. I want x values on one side and the numbers on the other side. That's why I'm gonna subtract 2x from both sides first to get rid of 2x on the right side. They cancel each out. 6x minus 2x is 4x plus 3 less than or equal to 19. Then I'm going to subtract 3 from both sides so that I can have just 4x is less than or equal to 16. And the next step is I need to divide both sides by the way, this is less than or equal to, this is less than or equal to sign. If we divide both sides by 4 right here, then x is less than or equal to 16 divided by 4 is 4. C2, 5x is between two values and we need to list the integers, but I'm looking for x, so why don't I just divide each side of this inequality by 5? Negative 5 divided by 5 is negative 1. 5x divided by 5 is x. And 15 divided by 5 is 3. And these are less than or equal to signs. Now I can list integers. X can be negative 1, negative 2. Sorry, x is greater than negative 1. So negative 1, 0, 1, 2, and 3. Question D2, I'm going to add 17 on both sides. Plus 17 here, plus 17 here. Then we will have 3x squared is less than or equal to 31 plus 17. That makes 48. And let's divide both sides by 3. X squared is less than or equal to 48 divided by 3 is 16. And if you take the square root of both sides, you will get 4. But x has to be between 4 and negative 4. Whatever that sign is, you need to use it right here. Question A3. Now we're gonna multiply or divide both sides by negative 1, which you need to be careful with one thing. Here, let's get rid of this 7 by subtracting 7 from both sides of the inequality. And negative x is greater than or equal to 15 minus 7 is 8. But I'm looking for x. So there are two ways of changing the sign. You can multiply both sides by negative 1, or you can divide both sides by negative 1. But if you do multiply or divide both sides by negative number in an inequality, then you need to use the opposite sign. So let's say if I multiply both sides by negative 1, I'm gonna use, let's say, blue one. Then negative 1 times negative x is positive x. Negative 1 times 8 is negative 8. But the greater than or equal to sign is going to change to less than or equal to sign. And this is going to be the final answer. Question B3. I need to have x on one side, numbers on the other side. That's why let's subtract 3x from both sides. And also, let's subtract 5 from both sides. Now I'm gonna do these two steps at the same time. 3x and 3x, they cancel each out. 9 minus 5 is 4. And 4x minus 3x is just x. And 5 and 5, they eliminate each other. So x is greater than 4 is the final answer. Or if you want to change it, you can say x is greater than 4 in this form. In the first one, it says 4 is less than x. X is greater than 4. They are both same. I just flipped it. And C3, list the integers values for x if I need to have a single x in the middle. That's why let's subtract 1 from all sides. 4 minus 1 is 3. 3x because 1 and negative 1, nothing. And 12 minus 1 is 11. Then I'm going to divide both sides by 3. Now, here we need to be careful with decimal numbers and integers. 3 divided by 3 is 1. In the middle, we have x. And we have 11 divided by 3. 11 divided by 3 is 3 point something. It's not 4. So it is 3 point something. You don't have to know exactly what it is. It says integer values. As you know, integers are positive and negative whole numbers. So x can be 1, it can be 2, and also it can be 3. Because 3 is less than 3 point something. That's why 3 also possible integer value for x. So 1, 2, and 3 is the answer. Question D3. Let's add 13 on both sides to get rid of this negative 13. And we will have 5x squared is less than or equal to 32 plus 13, which is 45. And I can divide both sides by 5. If you do it, you will have x squared. I'm going to write down here, x squared is less than or equal to 45 over 5, which is 9. And if you square root both sides, you will get 3. And x is going to be between positive 3 and negative 3. Is the final answer. Question A4. Work out the integer values of x that satisfy both the inequalities. So we have two separate inequalities which we need to solve them separately, and we need to list the x values that satisfies both of them. Let's do it together. I mean, how it's gonna be possible? I'm the only one who's solving the question. Anyway, let's add 4 on both sides. And 3x, probably I need to use the other side. So if there's no space left in here, I'm gonna use the other side. We have 3x less than or equal to 11 plus 4 is 15. And if you divide both sides by 3, then the first one is x is less than or equal to 15 divided by 3, which is 5. Okay, this is the first one. In the second one, I need to subtract 3 from both sides, then 2x is greater than 6, and if you divide both sides by 2, then x is greater than 3. So I can just say these two as x is greater than 3 and less than or equal to 5. X is greater than 3, x is greater than 3, and x is less than or equal to 5. X is less than or equal to 5. Now I can list x values. So x can be 4 and 5 only. P4, work out the lowest integer which satisfies the inequality. Lowest integer. Let's subtract 3x from both sides and add 2 at the same time. And if you do it, 5x minus 3x, 2x. Negative 2, positive 2, nothing. Greater than or equal to 3x minus 3x, nothing. And 7 plus 2 is 9. And if you divide both sides by 2, this is 2, even it's too ugly, then x is greater than or equal to 4.5. 9 divided by 2 is 4.5. It says the lowest integer. So what is the lowest integer that is bigger than 4.5? Yep, it is 5. Let's do questions. C4, list the integer values for x if. Now this is a bit tricky question, as usually what I do is I just apply the same thing on 3 sides. Like if you subtract 1, we just subtract 1 from all sides. But in this example, this is valid for if you have just x values in the middle and numbers on the other sides. Where in this example, we have x values on 2 sides, or even in this next one, we have x which is unknown on 3 sides. In these cases, I need to split the inequality into 2 parts. Let me show you how. Let's say we have, I'm gonna copy the same question here. I'm just gonna use the same numbers, but I will split them here. This is our first inequality, and I'm gonna use the same numbers and that part as a second inequality, and I will solve them separately like I did in the first question and put them together. And the second inequality is 3x plus 1 is less than 13. Let's solve the first one. I need to subtract 2x from both sides, but on one side I need x, on the other side I need number, and let's subtract 1 from, or I think it's going to be confusing, so let's continue. 2x minus 2x, 0, 0, it follows here, 0, less than 3x minus 2x is x plus 1. As you can see, we have x and a number on the same side. I don't want it, so let's subtract 1 from both sides. It follows negative 1 x. This is the first part. The second part, I'm going to solve the red one. Let's subtract 1 from both sides. Then 3x is less than 12. Then we can divide both sides by 3. And it is x is less than 4. This is the second part. Now I'm going to put them together again. X is greater than negative 1 and less than 4. And obviously, I'm going to write x in between. From the blue one, x is greater than negative 1, and from the black one, x is less than 4. It says list the integer values. So in this inequality, x can be, let me use which color? X can be 0, I'm going to use green one again, 1, 2, and 3. And the last question, Again, as you can see, we have x unknown in 3 parts of the inequality. I'm going to split it into 2 parts. Let's say this is the green one and the blue one is right here. Be careful with the signs again. In the first one, it is 2x. We divide it. 2x plus 3 is less than 4x plus 5. And the second one is 4x plus 5 is less than or equal to 3x plus 7. Obviously, these type of questions takes more time. You need to be patient and be careful when you do your calculation. Let's subtract 2x from both sides and subtract 3 also. So 2x minus 2x, nothing. Negative 3, negative 3, nothing. So we have just 0 left. Less than 4x minus 2x is 2x. And 5 minus 3 is positive 2. But I want x on one side and number on the other side. So let's subtract 2 from both sides again. Negative 2 is less than 2x. Let's divide both sides by 2. Be careful, I am dividing by positive number, so I'm not gonna change the sign. Negative 2 divided by 2 is negative 1. And 2x divided by 2 is x. Finally, I solved the first part. Second part, let's subtract 3x from both sides. And 5 also from both sides. 4x minus 3x is just x. 5 minus 5 is 0, less than or equal to 3x minus 3x, nothing. 5 minus 2, 7 minus 5 is 2. Okay, now I got the second answer. Let's put them together and list integer values. X is in between. Use the black one. X is in between from the first one. X is greater than negative 1. And from the second part, x is less than or equal to 2. So possible values, x cannot be negative 1, but it can be 0, 1, and 2. So that's it. We have solved 16 exam level questions. I hope it was helpful for you, and thanks to mathsforeveryone.com for providing us these questions. See you in the next video.